So the new chapter for today is matrices, or in singular form we just say it as matrix. Okay, so we'll start with this chapter. So it's very simple. So class 10 matrix is very simple. It'll start getting complicated when you reach to like 12 or 11. So it becomes a little bit tough there. Here class 10 matrices are very simple. So first thing you need to know is what is matrix, right? So what is a matrix? So matrix is basically a combination of data, right? Combination of data in this kind of form. So we have, like, let's say 1 2 3 4 5 6 7 8 9 10 11 12. So now this is a matrix. Now this means data is stored in a particular manner. So data is stored in the form of rows, in the form of columns, right, one after the other. So we just, like, for if we considered x to be a variable, right, we could just store a value x equal to 5. Now we can consider, let's consider x to be a matrix, then we can store a more number of values for x. Let's say 1 2 3 4 5 6. So x can be any of these values, right? So matrix is basically an expanded form of data storage. So the way you it's a system of storing data, right? So representing data in certain form. So matrix is representing data in this kind of form. So here we represent it by two square brackets, and inside the square brackets we put numbers and alphabets and values and whatnot. So I can put A, B, C, D, E, F. So this is also a matrix, right? So matrix is basically a collection of data. So a matrix is basically a collection of data in this kind of form. So I'll just repeat the form again. So matrix भनेको चाहिँ we are trying to represent data in form of rows and columns. We are trying to represent data in forms of rows and columns. So we store data in rows and columns. Like, we represent matrix as two square brackets, and inside that we store values in rows and columns. So I store values as 1 2 and 3 4 5 and 6. So in the first row, so this is the first row, right? So horizontal ones are called rows and vertical ones are called columns. So that should be known, that should be clear. So this is rows, this is the first row, and this is the second row. This is the first column, this is the second column, this is the third column. So this is how we represent data in matrix. So is this clear? Matrix is basically representing data in this form, right? You can have any number of values inside these square brackets. Just to form one, you can keep any number of values inside it. So is it clear what is matrix? So if this is clear, we'll move on to another topic known as order of a matrix. Order of a matrix.
Clear, sir.
Okay, order of a matrix. So we'll go to the next topic. This is also very simple. Order of a matrix. Okay, so basically order भनेको चाहिँ order, ORDER, order is basically the product of, but we don't find the value, okay, product of number of rows by product of number of columns. So this is number of rows, M represents number of rows, and N represents number of columns. So for this matrix, so let's say this matrix is represented as capital X. So this matrix has how many rows? 1 2 rows, right? So M is represented as 2. And how many columns? It has 1 column, 2 column, 3 column. So 2 by 3. So we read this as 2 by 3. We don't multiply the value and write it as 6. We don't write it 6. This is incorrect. So order is represented as M into N, M cross N, where M is the number of rows, N is the number of columns, and we read it as 2 by 3. So this is a 2 by 3 matrix. So X is a 2 by 3 matrix, right? Which means it has 2 rows and 3 columns. So by this, if some matrix is 2 by 3, then it has 2 rows, 3 columns. If some matrix is 2 by 2, then it has 2 rows and 2 columns. If some matrix is let's say 4 by 3, then that matrix will have 4 rows and 3 columns, right? So order of a matrix can define the number of rows it will define the number of rows and number of columns in a matrix. By order of a matrix, you can actually find the number of rows and columns in a matrix. Okay, so order is basically m cross n, where m is the number of rows, n is the number of columns. So is this clear? Okay, so now we move on to the next topic, is the elements of a matrix. So this is also relatively very simple. Elements of a matrix. So if I make a matrix something like 1 2 3 4 8 9 10 11 20 24 25 26, so it can be anything. Okay, it can be any random value. Now elements of a matrix basically is the element, the values or the numbers or the variables, whatever is placed inside a matrix. So this is the element of a matrix. So this belongs to row 1 column 1. So this is basically a1 comma 2. So this is the a1 comma 2 a1 comma 1 element of a matrix. So how do you know that? So we can represent this matrix as just by writing this. So this is the element in the first row, first column, right? First row, first column. So this can be represented as an element A in first row, first column, a1 comma 1, or basically it's written as ai comma j, where I is the number of row and j is the number of column. So basically 1 can be written as a element A in the first row, first column. Now if we move on to the second element, so element is basically everything that's inside a matrix. Okay, it can be a number, it can be a variable, whatnot. So if I go for this 2 is basically nothing but an element of a matrix which is in the first, which is in the which row? Second row, right? So it is in the first, this is the first row, this is the second row, which is in the second row but still the first column. So A 2 1. Now if I consider 3 is also an element of the matrix which is in the third row, but still the first column. 4 is also an element of this matrix which is at the fourth row but still the first column. So is this clear how to represent the elements of a matrix? So if you go for 8 again, so if I say 8, so this is also an element A of the matrix which is in the first row but now in the second column. So similarly it goes on for this all the values. Now if we consider this 25, this 25 is also an element of the matrix A which is in first, second, third row and first, second, third column, 3 comma 3. So A 3 comma 3 is basically the element of this matrix which is at the third row and third column. So is this clear, the representation of matrix?
Dada,
Yes.
त्यहाँ माथि नि तपाईले भन्नुभयो नि INJ, I represents
Yes,
row
I
and
represent
J
number of rows, J represent column. Yes.
How to say we can use any letter?
Yes, you can use any letter, but this is a norm, the standard way of telling ki, like most of the books use INJ. Okay, you can use any alphabet, it doesn't matter. So nothing is compulsory. Like there is a norm, there is a system that you need to follow, right? System that is like followed so that it becomes easier for the examiners to correct the paper, right? Because there are so thousands of schools around the country, right? Which belong to the ICSE group of schools. And if all the students use different norms and different alphabets, it'll be a big problem for the examiner. One student may write I as row and J as column, right? But someone else may write J as row and I as column, right? Now that will be a big problem to the person who's correcting the paper, right? So what they do is they put a norm, they put a standard alphabet for representing certain values, okay? And it's not a hard and fast rule to follow that. You don't need to write INJ. You can write any other alphabet. It doesn't matter, right? But if you want to like reduce the burden of the examiner so that he or she can correct more efficiently, then just follow the norm, okay? So there's no hard and fast rule. Follow गर्नै पर्छ भन्ने केही छैन. You can do whatever you want. You can put any alphabet you want, okay? So this applies not only to this part of this chapter in mathematics. It can apply to any chapter in mathematics or physics or chemistry. Okay, it is not a hard and fast rule to represent something with the variable that is always given in some books. Okay, Only thing that is hard and fast is the SI unit. SI unit is always hard and fast. So you have to always represent length in meters, right? Time in seconds, then what else? Velocity in meter per second or kilometer per hour, whatever it is, right? So there is a rule, like for this you have to follow this. You can't just write your answer in centimeter per second, right? You have to write in meter per second. So that is the SI unit you need to follow. That is a international system that is followed everywhere, right? But this is a variable that is just practice, right? That is just made common to everyone so that it becomes easier for everyone to deal with. You can take anything you want. It is hard and fast rule ke China. Okay. So this is how you represent the elements of matrix A I comma J, where I represents the number of rows and J represent the column number. So basically, if I want to represent this 11 now, so it is an element of matrix A which is in the first, second, third, fourth row, and first, second column. So A 4 comma 2. So by doing this, you can represent every element in the matrix. Okay. So this is how you represent a matrix. Now let's move on further. There's few more theory. Only it's a theory hour. After that, we'll go to numericals. So we'll have to study all the types of matrices now. Types of matrices. Okay. So first type of matrix that we need to study is a row matrix. It's very simple. So row matrix is a matrix which has only one row. Yeah. Row matrix is a matrix that has only one row. Like for example, if I have an matrix as 1, you don't need to put comma, 2, 3, 4, 5. So this matrix has only one row, right? But it can have more than one column. So 2, 3, 4, 5 columns, right? So a matrix with only one row but any number of columns, right? Doesn't depend on the number of columns, but it only depends on the number of rows. So if there is only one row in a matrix, that kind of matrix is known as a row matrix. Okay. Similarly, the second one will be the column matrix. Column matrix is basically which has only one column, right? And it can have multiple rows. So it just has one column but multiple rows. This is the first row, this is the second row, this is the third row, this is the fourth row. Okay. So this is a column matrix. Then the third we need to go is square matrix. Now square matrix is a matrix in which number of rows is equal to number of columns. So again, I had given you a norm, alphabet to represent something. So I represented M with number of rows and N with number of columns. So if a matrix has equal number of rows and columns, then it is a square matrix, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this matrix has 3 rows, 3 columns. So now this is a square matrix. The fourth one is a rectangular matrix. Rectangular matrix. So a rectangular matrix is where the number of rows is not equal to number of columns, right? So a rectangular matrix may be something like 1, 2, 3, 4, 5, 6. Now this is a rectangular matrix because it has 3 rows and just 2 columns. 1 column, 2 columns. So now the number of rows is not equal to number of columns. So this is known as a rectangular matrix. Okay. So these 4 are basic simple types of matrices. There are 2 more, I think. Not 4, 5, 6. Yeah, there are 2 more matrices. 3 more matrices. So you need to know about this. Okay. So this is a row matrix where only one row is present, but it doesn't depend on the number of columns. You can have any number of columns. Column matrix is a matrix where there is only one column but n number of rows. Square matrix is a matrix in which the number of rows is equal to the number of columns. And a rectangular matrix is a matrix in which the number of rows is not equal to number of columns, right? So the other types of matrices are, then we have a type of matrix called identity matrix. 4, 5. Identity matrix, or we just represent it as I. So I is basically a square matrix. I is basically a square matrix. So I is basically a square matrix with the diagonals as 1. So only the diagonals are 1, remaining everything is 0. So this is identity matrix which has 3 rows and 3 columns, right? I can have another identity matrix with 2 rows and 2 columns. So this is an identity matrix with 2 rows, 2 columns. So an identity matrix is a matrix which is square always. So square one, its number of rows should always be equal to number of columns, right? It's a square matrix whose main diagonal is 1. So this diagonal is always 1 and the remaining elements are always 0. Okay, so square matrix whose main diagonal is 1 and every other element is 0 is known as an identity matrix. It's represented by I. So is this clear, or do I need to explain it again? Do I need to explain it again?
No.
No? Okay. So this is the identity matrix. Just remember, identity matrices are nothing but square matrices, right? They are square matrices whose diagonal element is every diagonal element is 1, right? Main diagonal element is always 1 and the remaining elements are always 0. Okay? So this is an identity matrix. Then we have a diagonal matrix. So a diagonal matrix is also a square matrix. I think so. Yeah, diagonal matrix is also a square matrix whose diagonal elements are diagonal elements have numbers, like let's say 2, 3, 4, but the remaining elements are always 0. So the only difference between a diagonal matrix and an identity matrix is that in identity matrix the number is always 1, right? But in a diagonal matrix the number may not be 1 only. It can be a number greater than 1, a number less than 1. You can have something like this. A diagonal matrix has -1, -2, 0, 0. So this is also a diagonal matrix, but not an identity matrix, right? So these two may look similar, right? Identity matrix and diagonal matrix may look similar because they have this the almost same structure, right? They have zeros all over there, all over spread around the matrix, and the diagonal is a number, right? But the difference is identity matrix will have all the diagonal elements as 1. So all the diagonal elements as 1, right? All the main diagonal elements as 1 and the remaining terms as 0. Now for a diagonal matrix, the diagonal elements are not only 1, but it can be any number greater than or less than 1 or even 1, right? You can have even 1 here, 1 and -2. So now this is a diagonal matrix, right? It's not an identity matrix now. So identity matrices, they have only 1, they have only ones in their main diagonal, while a diagonal matrix is a matrix where the diagonal elements are not only 1, but can be any other value other than 1 as well. So is this clear? Then the last type of matrix is very simple, 0 or null matrix. So 0 or null matrix is nothing but a matrix with all the elements as 0. Right? So 0 or null matrix is nothing but matrix with all the elements as 0. Very simple. Okay, so I'll revise the different types of matrices once again. So first we did the 4 different types of matrices, the simple ones. Row matrix is any matrix which has only one row, but it doesn't depend on the number of columns. There is only one row, right? A column matrix is a matrix with only one column but n number of rows, more than one rows. Here more than one columns, here more than one rows. Square matrix is a matrix where the number of rows is equal to the number of columns, so m is equal to n. A rectangular matrix is a matrix where m is not equal to n, which means the number of rows and number of columns are not the same. So here in this case we have number of rows as 3, number of columns as 2, so m is not equal to n, right? Then we did the next 3 types of matrices. So these are the 4 simple types. Then we have identity matrix. Identity matrix is nothing but a matrix with the main diagonal elements as 1. So all the main diagonal elements are 1. They are all 1. While the remaining other elements in the matrix is all 0, right? And it should be a square matrix. This condition should be fulfilled. So it has to be a square matrix to be an identity matrix, right? All the main diagonal elements as 1 and other elements as 0. Then we have diagonal matrix. Diagonal matrix should also be a square matrix, right? It should be a square matrix whose diagonal elements are not zero and not only ones. It can be any other number as well, right? But other elements are always zeros. So other elements are always zeros, right? This also needs to be a square matrix. This is also a very important criteria, right? And the last one is the zero or the null matrix, where the entire matrix is filled with only zeros. So the matrix is completely filled with zeros only. Okay, so these are the different types of matrices.